All right, so these are our notes on regular polygons. Our goal for today, I can find the area of a regular polygon. And go ahead and rate yourself 1, 2, or 3. All right, so let's make sure we know what a polygon is. A polygon is any closed shape with 3 or more sides. A regular polygon means that all of the sides are equal and all of the angles in the figure are equal. This is technically a hexagon. Right here to the left here, that's a hexagon because it has 6 sides, but it's probably not the hexagon that you think of. It also is concave, so concave would have indents in it, like a star, so like this is a concave angle. So that's probably not what you think of when you think of a hexagon. This is probably right here what you think of when you think of a hexagon, and this is actually a regular hexagon, not because it's convex, but because it has 1, 2, 3, 4, 5, 6, what seem to be equal sides. They're not marked, but they are. And then 6 congruent angles also. So when it has, a hexagon has 6 congruent sides and 6 congruent angles, it's not just a hexagon, it's a regular hexagon. All right. The center of a regular hexagon is equidistant from its vertices. Okay, so this is the center of a hexagon, and these are all of its vertices. So there's 6 of them on a hexagon. Okay. That distance, so the distance from here to here, is called a word that you do know. So if I did my absolute, oh my goodness, very best to make a circle right here. Oh my goodness. Okay, let's do it this way instead. Circle. Okay, and I'm going to move it. And this is going to take up way too much time than I need to. Oh, it actually didn't take that long. Okay, so this distance from here to here, or this distance from here to here, we know what that's called. That's called a radius. All right, radius. And then we have another very important length right here. So this length, center to vertex right here, that's a radius. But if you look at this piece right here, this doesn't hit this right here. So it is not the same length. It's not a radius. That's called the apothem. An apothem, some people call it an apothem, but it's actually pronounced apothem. Apothem. So an apothem is from the center of the hexagon to the midpoint or the center of a side. I'm going to get rid of this circle here so that we can make sure we see it here. So it goes to the midpoint and it hits it at a right angle. So it's actually a perpendicular bisector, right? So you get a midpoint, so these two pieces are congruent, and then it makes a right angle. All right, so now we have something called a central angle. A central angle of a regular polygon has its vertex at the center, and then its sides pass through consecutive vertices. So I already erased my circle, but this right here is one central angle. Then we have another central angle. And then we have another central angle. Notice this would have 6 central angles. Now we know how many degrees all 6 of them make together. All 6 of them together make 360 degrees. So if I wanted each one in this hexagon, so if I wanted this one, let's say, I would do 360 divided by the number of sides, right? So if I did 360 divided by the number of sides in this one, which is 6, sorry, I did 60 on accident, 6, I'd get 60 degrees. So this angle 60 degrees, this angle 60 degrees, this angle 60 degrees. And now I have one right here too, but notice it's broken into 2 congruent angles. So if I want each one of those, divide it by 2, and I get 30 degrees and 30 degrees. And that's what we're going to have to do, is we're going to have to find this angle right here, or this one, it doesn't matter, okay? So we'll need to find this angle. And that has a measure of 360 divided by the number of sides, and then you divide that by 2. Okay? All right, and then once again, remember, this is the apothem, this is your radius, this is a right angle, and these 2 pieces are congruent. All right, so let's go ahead and see what the area of a regular polygon is. So to find the area of a regular polygon, we have the area is equal to 1/2 the apothem, which remember this was the apothem, times the perimeter, okay? And perimeter is all the sides added up. Just as a reminder. And then the A once again is apothem. All right, before we get started, sometimes there won't be a picture drawn. It'll just say that it's a regular octagon or a regular hexagon. And we have to make sure we know how many sides a shape has. So we'll go through each one of these. So if a shape has 3 sides, it's called a triangle. Now, if it's a regular triangle, usually we don't say regular triangle. Usually we say equilateral triangle, right? So an equilateral triangle is a regular triangle. 4 sides. Now, when I ask students, all right, what's called 4 sides? You'll automatically jump to square. Now, a regular quadrilateral is a square, but just any 4-sided shape is called a quadrilateral. Quadrilateral. Okay. 5-sided figure, pentagon. Then we already saw a hexagon today. 7 sides is a heptagon, sometimes called a septagon too, but we call it a heptagon here. 8 is octagon. 9 is nonagon. 10 is decagon. Now, 11 has a name, but we don't use it. We just say anything that we don't know. So the ones that we know are 10 and 12. So let's skip 11 for a second. 12 is a dodecagon. Whoa. Dodecagon. So like I was saying before, like 13-sided, we just say 13gon. 14 is 14gon. So whatever number of sides it is n-gon. So 11 does have a name, but we don't use it, so we just say 11gon. Okay. All right, so let's get started with some examples. So there's 4 examples here, ending with a U try, and it's just a different figure each time. Oh, look, and it has the rating right in the middle of it on accident. That's okay. It's at the end too. Good. Okay, so maybe it's a middle of the ropes rating. That's what we'll do. All right, so find the area of the regular hexagon. This is telling you that it has 6 sides with a side length of 10 feet. Round your answer to the nearest hundredth. So I'm going to start by saying my formula is area equals 1/2 apothem, which I wasn't given, so I'll leave a space for it, times perimeter, which technically it didn't say the perimeter is, but it did tell me that each side is 10 feet, and I know I have 6 sides. So for the perimeter, I can do 10 times 6, which is 60. So I do have that. So what I'm missing is the apothem. So what we're going to do is we're going to draw the apothem in the hexagon. So we're going to draw a center. We are going to connect it to the middle of one of the sides of the hexagon. I tend to just go to the one that's on the bottom because I like it. Okay. I'm going to draw my right angle. I know that this is cut into 2 congruent pieces. I'm looking for the apothem, so I'm going to put A there, and then I'm also always going to make a radius. Okay, so now I have to have been given, if I'm looking for the apothem, I either have to know the radius or I have to know this piece. Since I know each of the side lengths is 10 and it's cut into 2 congruent pieces, I know that this is 5 feet. All right, now I'm going to find this angle, which we learned how to find that angle, and we actually already know it's 30 degrees from our previous example, but let's say we forgot it. 360 divided by the number of sides, so 360 divided by 6 is 60 degrees, and then divide that by 2. So we get that angle is 30 degrees. So now to find the apothem, we are going to use either SOHCAHTOA, or we can use the fact that this is a 30, 60, 90 triangle. So for this one, let's use the fact that it's a 30, 60, 90 triangle because it's less work. So this is 60 degrees, right? Across from the 30 is my 5-foot side. That means across from my 60 is 5√3. So the apothem is 5√3. It's less work, right? I could use SOHCAHTOA, but I didn't feel like it. So now I'm going to put this in my calculator so that I can find the area of this hexagon. All right, get my calculator up and running. Move this off to the side here. Hit clear. Okay, so I like to type this in first. So I'm going to do 5√3 And I could have put that in parentheses, but I'm just going to put the 60 in parentheses. Oh, but that's not going to work. So let me get a parentheses, 60 parentheses. All right, so 5 root 3 times 60. And then I have to divide that by 2. Hit enter, and I get 259.81. So the area is 259.81. And then remember, this was feet times feet, so it's feet squared. Okay? Now, if it's not a 30, 60, 90 triangle or a 45, 45, 90 triangle, we will have to use SOHCAHTOA. So we will see that. All right, this one. Find the area of the regular octagon with an apothem of 12. So this time I gave you the apothem. Round to the nearest hundredth. Did the other one say that? Yeah, it did. All right, area equals 1/2 apothem times perimeter, right? So I'm going to do area equals 1/2. I need the apothem, which is 12, or I have the apothem, which is 12, but I don't have the perimeter. So I'm going to leave a space for it. All right, so I need to find the perimeter. All right, I'm going to draw in the center. I'm going to make the apothem. Now, whenever I draw our apothem, it makes a right angle, 2 congruent pieces. And once again, you can do this to any of the sides. I could have drew it right here, but I like it the way I have it. All right, the apothem was 12. Okay, and then I'm going to draw on the radius. And then remember, I always have to be given one piece. I was given the apothem, and I'm looking for the perimeter. So if I'm looking for the perimeter, what I'm going to do is I'm going to call this X right here, right? Because whatever I get that is, so let's say I get that's 5, right? Let's say I solve it, I get X is 5. Then I know the side length is 10, and then I can multiply it by 8 to get the perimeter, right? So I just need to find that X value. All right, so let's find that X value. We're going to find the missing angle. To find the missing angle, we're going to do 360 divided by the number of sides. This is an octagon, so 8. 360 divided by 8 is 45. Okay, and then divide that by 2, which is 22.5 degrees. So this angle is 22.5 degrees. If it was 45, I could use a 45, 45, 90, but it's not. Okay. So instead, I'm going to have to use SOHCAHTOA to solve for X. So here is my angle. This is opposite, and this is the adjacent side. So I'm going to use tangent. So I'm going to do tangent of 22.5 degrees is equal to opposite over adjacent. Cross multiply to solve for X. X equals 12 times tangent of 22.5 degrees. Remember, I'm not putting this in my calculator because it's going to give me a decimal, and then I'm not giving my final answer yet. So now, and one thing that people do wrong is that they throw this in here, but remember, that's not the perimeter. That was this little piece right here. So now what I'm going to do is I'm going to find the side length. To get the side length, I'm going to multiply this by 2. So I'm going to do 2 times 12 tangent of 22.5. I can clean this up a little bit because I can do 2 times 12, and I get the side length is 24 tangent of 22.5. So now I have the side length is 24 tangent of 22.5, and now I need the perimeter. So to get the perimeter, let's get another color going here, which is what goes in my formula. There are 8 sides. So I have to do 8 times 24 tangent of 22.5. And I can clean this up a little bit by doing 8 times 24. So I'm going to do 8 times 24, and I get 192. So the perimeter is 192 times tangent of 22.5. And that's what I'm using for perimeter. So I'm going to put that in here, 192 tangent of 22.5. And now I'm going to put this in my calculator. One thing I could do is I could do this mental math and say that's 6, and then I can type 6 times 192 tangent of 22.5, but I don't want to make any mental math errors in the future, so I'll do it the way that always works. 192 tangent of 22.5, close parentheses, times 12, and I could have done the 12 first. Enter. Divided by 2. Enter. And I get 477. Area is equal to 477.17. And then don't forget your units. Your units are, where'd they go? Centimeters. So centimeters squared. Right? Well, there's a goal in the middle of the notes, so maybe see how you're doing so far. Okay? All right. Couple more here to try. I got one to try with you, and then you can pause the video and try the last one on your own and just check your answer. Okay? All right, so this one says find the area of the regular octagon. So another octagon with a perimeter of 96 centimeters. So we're going to start off by saying area is equal to 1/2 apothem times perimeter. Area is equal to 1/2. I was not given the apothem this time, so I'm going to leave a space. Notice I leave like a bigger space because I know it's not going to be, more likely not to be pretty than it is to be pretty. And then the perimeter I was given this time, which is 96. Okay, so now I'm going to draw in my apothem. There's my center. Make my right angle, my two congruent pieces, and then I don't have my apothem, so that's A. I wasn't given my radius, but that means I have to know this piece, which I do. Okay, so let's figure it out. The perimeter is 96. Divide it by 8. That'll give me each side length. So 96 divided by 8 is, each side length is 12 centimeters. 12 divided by 2 is 6 centimeters. So that little piece right there is 6 centimeters. Now I need to find this angle right here. I know it's 22.5 degrees. Why do I know it's 22.5 degrees? This math right here. It's another octagon. It's not going to change. Okay. Doesn't change the fact that it's an octagon. That's still 22.5 degrees. Okay. All right. So let's find the apothem. So here's my angle. This is opposite and this is adjacent. So we have tangent of 22.5 degrees is equal to opposite, which is 6, over adjacent, which I called A for apothem. Put this over 1, cross multiply. I have A times tangent of 22.5 degrees is equal to 6, and then divide both sides by tangent of 22.5 degrees. Let's cancel, and I have A equals this. Okay, so I have A equals this. So I'm just going to copy and paste it. Copy, paste. Could have just left it there. And now I'm going to replace apothem in my equation with 6 over tangent of 22.5. Notice this is less work because I just had to find the apothem, not the perimeter. And now I'm going to type this into my calculator. So I'm going to start with parentheses, 6 divided by tangent of 22.5, close the parentheses, times 96. Oops, that's not 96. Let's delete that. Hit enter and then divide this by 2. And I get 695.29 centimeters squared. All right, why don't you pause the video, try this last one, and then you can fast forward to the end, see how you did, or check the answer key compared to yours and see how you did. And if you didn't get it right, you can watch this part. If not, you can go ahead and start on the homework. All right, so to do this one, I know area is equal to, it says I should read, find the area of the regular pentagon with a side length of 4 inches, round to the nearest hundredth. So 1/2. Apothem I wasn't given, so I'll leave a space. And it doesn't say what the perimeter is, but it takes me 2 seconds to find the perimeter. The side length is 4 inches, and there's 5 of those sides. So 4 times 5 is 20 inches. All right, so what I don't have is I don't have the apothem. So I'm going to put a center inside that pentagon. I'm going to drop an apothem, which means I have a right angle and 2 congruent pieces. I'll put an A for apothem. And then I need this little piece. 4 divided by 2 is 2. So this is 2 inches. Then I need to get this angle right here. So to get this angle, I'm doing 360 divided by the number of sides, which is 5. That's 72 degrees. And then divide that by 2, which is 36 degrees. So this angle right here is 36 degrees. All right, so I'm going to use SOHCAHTOA because it's not a 30, 60, 90 or a 45, 45, 90 triangle. Here's my angle. This is opposite. This is adjacent. So I'm using tangent. Tangent of 36 degrees is equal to opposite, which is 2, over adjacent, which is A, and then cross multiply to solve for A. A times tangent of 36 degrees is equal to 2. Divide by tangent of 36 degrees. These cancel, and you have your apothem is 2 divided by tangent of 36 degrees, and now I can put this in my calculator. So parentheses 2 divided by tangent of 36, close the parentheses, times 20, divide that by 2, and we get our answer is 27.53. So area 27.53 inches squared. If you got that, great job. If not, try to see the mistakes that you made. And then you can go ahead and get started on your homework after you rate yourself. How do you think you're feeling about regular polygons?